Okay, so I'm going to start going through problems 15 through 21 with you. If you need to pause this as you're going through so that you can write out the correct setup or make sure that you've gone through the calculations correctly, please pause the video and do that. All right, we're going to start off with problem 15, A and B. 15 says determine the mass in grams of each of the following. So we're going to take a molarity and change that into grams. So 3.57 moles of aluminum, and we want to find grams. So we begin by saying 3.57 moles of aluminum. So whatever they give us, a great place to start is to put that number down. Then 1 mole of aluminum weighs 26.98 grams. We can cross out moles. We're left with grams. We do the multiplication across, and you end up with 96.3 grams of aluminum. For 15B, same idea. You have 42.6 moles of silicone. So we have 42.6 moles times 28.09 grams over 1 mole. We can cross out moles. We're left with grams, and your answer is 1.2 times 10 to the 3 grams. All right, 16A. The problem says, convert each given quantity in scientific notation to mass in grams expressed in scientific notation. Okay, so your final answer here has to be in scientific notation according to the problem, but it also needs to be in scientific notation because, as I told you, if the problem itself involves scientific notation, then the answer needs to. Okay, so we know that we have 3.45 times 10 to the second moles of cobalt. All right, so we put that down here first, 3.45 times 10 to the 2 moles. We multiply that by 58.93 grams. That's the molecular weight. We divide by 1, so we can cross out the moles, and you're left with 2.03 times 10 to the 4 grams. Okay, because we have grams left here. All right, 16B is going to be the same way. 16B has given you 2.45 times 10 to the negative 2 moles of zinc. Okay, so you take this and put it down here first, 2.45 times 10 to the negative 2 moles times the molecular weight, which is 65.38 grams, divided by 1, and we can cross out moles. We're left with grams, 1.6 grams of zinc. Okay. All right, 17A. The question says determine the number of moles in each of the following. So you have 25.5 grams of silver. Okay, so we have 25.5 grams of silver, and we need to get to how many moles there are. So we start with 25.5 grams. 1 mole is 107.9 grams because silver weighs 107.9. We can cross out grams. We're left with moles. We divide here, so 25.5 divided by 107.9, and you're left with 0.236 moles. You could also, if you wanted to, change this and make it 2.36 times 10 to the negative 1 mole if you wanted to, but because there's not scientific notation here, this answer would be just fine as well. All right, 17B tells you that you have 30 grams of sulfur. You need to find the moles. So we take, 300 grams of sulfur. So we take the 300 grams, we divide it, so we have 1 mole is 32.07 grams. We can cross out our grams. We're left with moles. We divide here, and we get 9.355, or you could make that into 9.36 moles of sulfur. All right, 18. 18 says convert each mass to moles. Express the answer in scientific notation. So we're going to start off with a mass here, grams, and we need to give it in moles. So 1.25 times 10 to the 3rd grams of zinc. We put that down here first. We multiply it by 1 mole of zinc, which weighs 65.38 grams. Here we're going to be able to cross out, this is grams, cross out grams. We're left with moles. We divide and end up with 19.1 moles of zinc. All right, 18B. They give us 1 kilogram of iron. Now, you can do this two ways. The long way, which is completely fine if this is how you're understanding it, is to put that 1 kilogram, this is 1 kilogram, yeah, 1 kilogram of iron. We put the kilogram down here, and now we're going to need to change it to grams, because when we're dealing with moles, everything's in grams, not in kilograms. So 1 kilogram, we're going to multiply that times 1,000 grams in 1 kilogram, so we can cross out those kilograms. Then we need to get to the molarity. So now we have 1 mole of iron weighs 55.85 grams. We can cross out grams. We're left with moles. We do the multiplication and the division, and now you have 17.9 moles. You need to change that. You can change that, you don't have to scientific notation, where so you would have 1.79 times 10 to the first moles. Okay? On this one, you also could have just said 1 kilogram is equal to 1,000 grams and just started with this step, just saying that 1,000 grams times 1 mole over 55.85. Either way, as long as you begin your answer in grams, you're fine. Okay. All right, 19A. How many atoms are in each of the following samples? So we're going for atoms now. We've done moles and grams so far. Now we're going to try to find the number of atoms in something. So if you have 55.2 grams of lithium, okay, how many atoms is that? So we start off with 55.2 grams. 1 mole of lithium contains 6.94 grams. Now we need to get to the atoms part. So we've crossed out grams. We now know that 6.02 times 10 to the 23rd atoms are in 1 mole. So we can cross out moles, and we're left with atoms. We multiply across and then divide, and your final answer is 4.79 times 10 to the 24th. All right, 19B. We're trying to find how many atoms are in 0.230 grams of lead. Okay, so we put the 2.30 grams down. 1 mole of that weighs 207.2 grams. We can cross out the grams. 1 mole contains 6.02 times 10 to the 23rd atom. We can cross out moles. We're left with atoms. After you multiply and divide here, you're going to have 6.68 times 10 to the 20th atoms. All right, if you're having problems with the scientific notation on this, please come talk to me, okay? We can talk about why this is to the 20th. Okay, number 19C. All right, in 19C, we're told that we have 11.5 grams of mercury. Again, we put that down here, 11.5 grams of mercury. 1 mole of mercury weighs 200.6 grams. We can cross out the grams. 1 mole has 6.02 times 10 to the 23rd atoms. We cross out moles. We're left with atoms. Multiply and divide, and we get 3.45 times 10 to the 22nd atoms for 19. Okay. Problem number 20. It says, what is the mass in grams of each of the following? So we're given a certain number of atoms, and we need to find grams. So 6.02 times 10 to the 24th, the number looks somewhat familiar, just with a different, with one more number on the scientific notation. So this is atoms of bismuth. So we start with that, 6.02 times 10 to the 24th atoms. 1 mole contains 6.02 times 10 to the 23rd atom. We can cross out the atoms. Then we know that 1 mole of bismuth weighs 209.0 grams. We can cross out moles. We're left with grams. So our final answer is 2.09 times 10 to the 3rd. Okay? Remember that in division with scientific notation, you're going to subtract. Okay, so just keep that in mind. All right, 20b. We're given 1 times 10 to the 24th atoms of manganese. Okay, 1 times 10 to the 24th atoms. 1 mole has 6.02 times 10 to the 23rd. We cross out atoms. 1 mole of manganese weighs 54.94 grams, so we can cross out moles. And then here we're left with just grams. Here we go. Go through, and here all you're going to need to do is divide, and you end up with 91.3 grams of manganese. That's 20b. 20c, we have 3.4 times 10 to the 22nd atoms of helium. Put down 3.4 times 10 to the 22nd atoms times 1 mole over 6.02 times 10 to the 23rd atoms. We can cross out atoms. 1 mole of helium weighs 4.003 grams. We can cross out moles. We're left with grams. And your final answer is 0.226 grams of helium. All right, 20D. These were a lot of problems. Okay, 20D gives you 1.5 times 10 to the 15th atoms of nitrogen. So 1.5 times 10 to the 15th atoms times 1 mole over 6.02 times 10 to the 23rd atom. Let's cross out atoms. 14.01 grams, the molecular weight of nitrogen, over 1 mole. Cross out moles. We're left with grams. So we have 3.49 times 10 to the negative 8 grams as your final answer. 20E, 1.5 times 10 to the 15th atoms of uranium. Yes? Yeah. So 1.5 times 10 to the 15th atoms times 1 mole over 6.02 to the 23rd times 238 grams over 1 mole. So we're going to cross out atoms. We're going to cross out moles. We're going to be left with grams here. So your final answer is 5.93 times 10 to the negative 7th grams. Okay. Final problems. Okay. Number 21. Convert each given mass to number of representative particles. So whether it's going to be atoms, or in this case they're both atoms, but if they were going to be molecules, you would say that as well. And they identify the representative particles and express the number in scientific notation. So they're giving us a mass. We need to say how many atoms there are. Okay? So 4.56 times 10 to the 3rd grams of, they like silicone. So 4.56 times 10 to the 3rd grams times 1 mole over 28.09 grams. We're going to cross the grams out. 6.022 times 10 to the 23rd atoms in each molecule, in each mole. Cross that out. We're left with atoms. Your final answer is 9.77 times 10 to the 25th atom. Atoms. Sorry. Okay. Final problem. 21b. We're given 0.120 kilograms of titanium. So again, you're going to either need to convert this before you get started, or do like I did here and have the conversion written in. So 0.12 kilos times 1,000 grams over 1 kilo. We can cross the kilos out. 1 mole equals 47.87 grams. We can cross the grams out. 6.022 times 10 to the 23rd atoms over 1 mole. We can cross the moles out. We're left with atoms here. So now we have 1.51 times 10 to the 24th atoms of titanium. Okay, please go back and look over any of these that you're not familiar with. Tomorrow, well, if you do this on Wednesday night, tomorrow we will be talking about the harder problems that we started in class today. If you don't do this until Thursday night, well, then hopefully you're still working on that homework. Okay, have a good night.